So, welcome to the afternoon sessions on our first day here at ESIP. Let's try to get this into slideshow and not break anything. So, this session, and I hope the folks online can still hear. Okay. I walk around a little bit. This session really, the idea for this really came out of, I think, a few other sessions throughout the week, was sort of born out of discussions we had back in, I believe it was March at the ESTSWG meeting. So a lot of NASA kind of oriented things going on here, but I do think a lot of these concepts are particularly broadly applicable in the realm of field data. And so I think it's really relevant to bring this to the bigger audience at ESIP for, additional discussion and ideas and ways in which to move forward. So a lot of folks involved here, not just me, I'm just happen to be the one standing here talking to you. So we had lunch, so I think it's really good. Everybody, whether physically or mentally, go ahead and stretch. Whether you like imagine firecrackers, bright lights, extra coffee, recharge, you need to move, make sure you're awake. We don't want people falling asleep in our sessions. The first time I worked on an ESIP session, so it would be especially demoralizing if you fall asleep in this for me. So please stay awake so that I will have the positive encouragement to continue on. Okay, so I think this is not brand new to anyone here, but just as a kind of reminder and setting some context, this figure is actually from a report that the National Academy put out kind of essentially towards the end of the NASA DC-8's life as a really great workhorse of an airborne research platform, and saying we need to have a future with that. And as you all know, we now have the 777, which will be kind of a new realm of those airborne observations. But it really speaks a lot to kind of the role that airborne and field, surface, sites, stations, whatever word you want to use, that they play in our ability to observe and understand the Earth. And so, yes, spaceborne things are very important, and they give us a really nice perspective that we cannot get otherwise. But really to make use of those and to really make good sense of those and calibrate those data properly and understand some of these really smaller scale things that we just can't fully observe from space alone, we must have these airborne and field data. So they really fill a vital link in being able to not only understand our satellite observations, but better model and understand these physical processes of our planet, particularly as it's changing. And yeah, so airborne and field, so that's where we are. So just a quick look, we're going to try to block out this session time to be roughly 1.5 hours and then a longer, more discussion oriented second half or 2/3. So first we're going to go over, kind of broad overview, and then Bruce Wilson will talk a lot about the NASA preservation content specification, some of the implementation guidance and things. We'll have a short kind of Slido activity where you get to play along. And then we'll talk and hear from a kind of speaker / panelists on examples of data preservation in real life. And we'll go through some kind of challenging parts of that. I have some topics we could discuss, or we can let that kind of naturally evolve. I'm open to either way. And then we'll tie up. So as we go through this discussion here today, I think it's really important that we take a look at what are our goals for this. We really want to have, again, stakeholders here across ESIP, not just NASA, on this idea of preservation and content that kind of goes along with these data to aid in that longer term use of it. I also think, there's other analogs, there's other implementations, there are limitations in what we can and can't do to complete these types of activities. And so having those discussions, again, not just NASA focused, but it really feeds in. And personally, one of our working group kind of ideas is being able to add in, now that NASA's PCS implementation guide's kind of been out in the wild for a little while, there have been some kind of just implementation things that have come up that we think maybe we can go ahead and do a revision on just the airborne and kind of field aspects of that. So trying to take notes from this discussion on what may apply there. Eventually, we're going to facilitate have ESCO facilitate a review of that guide. And so I'm really hoping all of you sign in on that session notes document. And you might be pinged as a reviewer one day in the future on that guide being reviewed. So some things to think about as we continue on here. What experience do others, as in NASA and non-NASA, have that's relevant to the NASA world? There's what call these like analogs of the PCS. So NASA has this specification. It's a very specific document that's in all of the notes for the session. But are there analogs to that in your organization? And are there challenges in interpreting that for specific cases of field or airborne data? What kinds of things does a data user, do we think a data user might want to know potentially decades down the road from when those data were collected? How do you know when it's appropriate to use in your use case or not? And this is kind of the never-ending question in a lot of things, but where's practical good enough versus perfect? You're probably never going to get to perfect. Can we get to good enough in a practical sense? And obviously there are lots of resource funding limitations and things that make constraints here. So just kind of think about all of these things as we go through. And I think with that, I'm going to actually call up Bruce to take over and kind of go through some of the from NASA side kind of preservation content specification and pieces of that.
Okay, so Stephanie's got this slide. I'll preface my comments by saying you either already understand the PCS or there's no way that I can present all of it in a useful time, but I'm going to present an overview and some summary comments about it. I stole this from Deb Smith. So, and the emphasis is mine. So we had an earlier session today talking about data governance. And there is an aspect of PCS, which is, it is absolutely data governance. And so Deb pointed out some challenges with data governance. And in particular, the three that I bolded here are challenges for airborne and field data. It tends to be diverse and complex. The PCS is not written for the scientist or someone new to data management. And emerging technologies present some challenges. So these documents are linked in the Google Doc, and I think they are also linked in the session description. So there is the PCS, revision C. There's an implementation guide, and that's probably an interesting signal that if you have a document and you need a separate implementation guide, there is a significant degree of complexity there to deal with. And then there's an Earth Data wiki space that has some additional resources that does require an Earth Data login. And if you run into some challenges getting into that, I put my email address in the Google Doc. Let me know and I can work with the folks that have governance over the wiki to make sure that people have access to that. So thinking about the PCS, and John Moses and I had some fairly long conversations about this. And it boils down to a degree of judgment that making sure that the long-term archive, that the DAC, preserves as much of the scientifically relevant information as is possible, or I might even say practical, about a mission, so that the data is as reusable, interpreted, even decades from now. And this is some interesting things for me to look at. The ORNL DAC has been in existence since 1993. As a consequence of the migration into Earth Data Cloud, we recently had reasons to look at things like data set number one and recognize we did the best job we knew how to do at that point in time. And if we did it today, we would do some things differently. So again, thinking about that same question, we're doing the best job we know how to do now. We can't necessarily anticipate where the world is going to be 20 or 30 years ago, but it's an interesting question to think about in the context of the preservation content specification. And I put some other notes in here and then some comments about where that initial version came from and how some of the things have evolved. And I will say that in the most recent revision of the PCS, there absolutely was an involvement from the field and airborne community. But there's also an element that as we've sat down and said, what does this document actually mean for us when the rubber hits the road? We've identified some things that weren't obvious to us at that point in time, and that's an aspect of what this whole session is about. See, you saw this slide earlier. Stephanie had a little bit of a repeat. So what are the things that are in PCS? Again, it's asking some questions about, well, how is this calibrated? What do we need to know? And it's one thing if we're talking about an on-orbit case where we got a very clear chain. But, we've got some data sets where, a graduate student went out and measured tree diameters at breast height. Do we look at the calibration of the tape measure that they were using? We've got some data sets that some other folks will talk about. And some that we didn't, somebody went out and measured above ground and below ground biomass. Do we calibrate balance that they were using? Or where do we keep that sort of information? Where is this line of what's practical? Again, algorithms, like we're pushing a little bit more on that. We haven't always kept the scripts and so forth that people used to do their data manipulation. In an awful lot of cases, quite frankly, the data manipulation was done in Excel. And preserving an Excel spreadsheet is not something that we would do. So again, what about airborne instruments or airborne and field data? And I've divided this up into sort of three different groups. One is the so-called facility instruments. So these are very mature airborne platforms. They're things like Avarice, Elvis, UAV, SOAR. It's the same group of people making data. We do have to recognize that those instruments are deployed at a specific place on a specific time for a specific reason. And that matters. I've talked with the Avarice team, and this particular set of flights was done to particularly focus on methane emissions. So that the way they handle the spectrometer, the altitudes that they were flying at, and some of the details about what data they produce and how they produce it are potentially different than if this is an Avarice mission in support of EMET, where they're trying to say measure mineralogy or some of these other kinds of things. But in general, these are the airborne and field data that are most like on-orbit data. They're a relatively reproducible process produced by the same size team over a period of time. And comparatively speaking, they're relatively well-funded. And there is a reasonable expectation of putting some level of burden on them and a very mature data management plan. There are some similar things in terms of long-term ground measurements, except that from my perspective, NASA doesn't really do these. We had some, there were places and times where NASA funded flux towers. But I'd say this is much more in the realm of NEON, LTER, plate boundary organization, and some of the other places that are doing these long-term on the ground measurements. And again, those have some resemblance in the sense of reproducible process, although again, things may vary over time. And I think Christine is going to talk to some of that from the NEON perspective. And then we get into what is most of what my DAC does, which is more like one-off airborne and field campaigns or larger programs. And these have a wide method of tools, including observation. One of the people on the ORNOVAC staff, Rupesh Shrestha, did some word clouds about the GCMD science keywords for the instruments and platforms that were used across the ORNOVAC. Observation actually was one of the ones that was, and in terms of the instruments, balance as in, the things that you measure mass on was one of the most commonly used instruments across our data sets. And again, conducted at a specific period of time for a specific reason, but most of these are individual PI-led projects. The PI might be getting $250K a year, and we're getting data from a graduate student or a postdoc. So at the above level, the Arctic Boreal Vulnerability Experiment, there's a fairly mature, well understood data management plan, but where are we trying to put, what burdens are appropriate to put on a small project like this, and what's practical? Again, there are some things that we could do, but if somebody's looking at this data set 10 years from now, do they care? And that becomes an interesting practical judgment. So this again gets to some of these overarching questions. What experiences do others have that's relevant to this question? What are the analogs? How do people interpret? What's the best practical answer? Some in this room are domain scientists. We have, some of those on various staff, and we rely on that judgment. What's somebody actually going to care about if they want to use this data, particularly in the case where the data is described by publication in the peer-reviewed literature? What do we do that's different from that? Although we do look at that question because NASA user guides are freely, openly available, but that peer-reviewed publication may be behind a paywall. So we do actually want to make sure that, okay, if it's an open science publication, we might draw the line a little bit differently than if it's in a publication that's behind a paywall, particularly a significant paywall. And frankly, those paywalls are getting worse over time. This is one of these things that we can always do a better job, but what's a good enough job? All right, so I'm gonna have to come over here and get this started. Make sure that this is actually started. Okay, so that slide is open, and I will share from here there in a minute. So there's a bit.ly URL up here, there's a QR code. And so this is an exercise to start thinking about this question. So we have a data from a 3-year project. It measured methane levels at 21 sites around 3 lakes plus some control sites. And they used this information to estimate annual methane emissions for the lakes. So we've got some information. That's what's specified here. And if you'd like, you can assume that this is a journal article that's going behind a paywall. Maybe if you really want to look at a worst case scenario, maybe it's even an Elsevier journal. So given this information with a little bit of some constraints, the Slido activity asks you, what 5 other things do you see as most important to preserve in the data sets and or its documentation? So I'll give you a few minutes to do that. And put it kind of in order, but I'm more interested in what, which 5 you pick. Zoom. I think what I need to do. challenge here, so I will I'll put the results in the Google document and grab them from here. So the top answer was laboratory calibration curves for each of the instruments. Second was the make and model of the instruments used to make the methane measurements and the popping back and forth. Source code for the MATLAB scripts, daily weather data, including temperature and precipitation, surface area of the lakes, the data logger. Nobody picked shoe size. Okay. So again, that's a sense for some of the questions. And then where we're going from here is, Stephanie, if you want your short break here, or did I just duplicate an extra slide? Oh, I see what happens. Yeah, okay. It's supposed to be, okay. Okay. Sorry about that. So what order are you doing there? Yep.
How much effort is it to find it?
Or, yeah. Or did they even save them? Again, a common situation for us is data producers said, hey, we just submitted the paper for this. We need a DOI. Here's the data. Can you get us a DOI tomorrow? And when we go in and look at this, well, hey, we'd like this information. Oh, we didn't save that. So again, some of this, and I'm going to put my plug in for some of the things that came out of last year or 2 years ago's Airborne and Data Workshop. The earlier that a data archive is assigned to a project, the better we can have these conversations with people. It's lower cost to whoever is the agency involved, because we just take a bunch of the speed bumps out of the process. All right, so Stephanie. Yeah, so other people are speaking to those other data sets. Rama? Yeah. So for those that are online, Rama's comment was that, yeah, some of the things that fell off the bottom of the list is because I made this a constrained problem, but it was intentionally a constrained problem because as a DAC manager, I have constrained resources. And part of the conversation that I have with my NASA people is, okay, how and where do you want me to spend this money? And what is most important to us overall? But yeah, good point, Rama. Hmm, okay. Yep. Yep. Right. And again, the question for those online was, did I miss anything in the list? And one suggestion was who reported the data? Yep. Yep. Right. So, and again, Rama's. Yep. Yep. So Rama's point is, again, some things aren't expensive to maintain if we get them into the DMP upfront, which is often a conversation with whoever is the archive for that data, whether it's a DAC and it's NASA or somebody else or a different funding agency. And then there's a comment in chat from Rebecca. We'll get through the Zenata community that they've applied for an HEE grant to enrich some data sets. So a little bit of going back into some things afterwards. Okay. I think we were moving into some examples.
Sure. Okay, great. Thank you, Stephanie. First, I'm going to follow the questions outlined there. I'm Yaxin Wei. I'm the lead scientist from the Oak Ridge National Lab Distributed Active Archive Center, or now DAC. It's one of NASA's 12 DACs. So DAC is the primary data repository for data derived from NASA's terrestrial ecology program and carbon cycle and ecosystem focus area. So the data example that I'm going to talk about today was from a major field campaign sponsored by the TE program. It's called Above, Arctic Boreal Vulnerability Experiment. The Above campaign started back in 2015, and it's still going on right now, but it's at its last final phase. So the Above focused on the high latitude region, Alaska and Western Canada, and the study the climate impact on the environment, how the interaction of different components of the ecosystem in the high latitude area are. So can I just click on? Okay, so this particular example that I'm going to show, let me enlarge that, is actually a field measurement data. And this data set contains a field measurements of photochemical reflectance index and tree growth for about 29 trees at a few study plots in Alaska, Brooks Range. But before I dive into this example, I want to give a comment on the overall strategy of how the DAC tackle to meet the requirements outlined in the PCS. So at the DAC, we tend to package all the useful documents, materials, for a particular data set, useful for users to kind of understand the data, to properly use the data in a well-established package. So we put everything together in a data package. Instead of listing things that, okay, these are the stuff that we preserve from this particular study. So, and we do that in a few different aspects. One is to curate really hopefully useful user guides that contain information like data characteristics, the metadata information at the project level, at the collection level, and methods used to, for example, quality assure, quality assessment of the results, and also some of the calibration information and the potential application of the data collected by the study, and the detailed methodology used to collect the data and to create the data. And also version history, related publication, related data sets. So a bunch of useful information that we pack together into a well-established user guide. And also that's the first thing. The second thing that we do is to include anything that's useful for users to understand the user data through so-called companion files. And the companion files are directly associated with the data set. And that information is also included in the metadata that we submit to the CMR. Okay, so that's the general strategy that we do to support PCS. And for this particular example, this is the landing page, and we give some really high-level information, the DOI and the project, and some usage metrics for this particular data set, and a brief description. But I really want to show you the user guide, because that's the key part. So let me click on the user guide. This is the user guide that Diurnal DAC actually put together through collaboration with investigators. They probably, unlike some other DACs that the investigators were required to provide documentation, but here at the Diurnal DAC, we work very closely with the investigators to establish such user guide, because most of the researchers that we support were just from relatively small research projects. So from this user guide, you can see there's a summary and there's a figure. For every data set that we publish at the Diurnal DAC, we require a so-called figure 1. This is a figure that most representative for a particular data set. And this, as you can see from the title, this data set contains two kind of measurements. One is the photochemical reflectance index, PRI. The other is the tree growth information measured simultaneously. These measurements will actually use two different sensors. One is the PRI, the measure the photochemical reflectance index, which is kind of an indicator of the tree productivity and tree health. And associate that kind of PRI measurements with the tree growth. For the tree growth, this sensor is actually more advanced than the one that Bruce just mentioned. So it's not using tape to measure the diameter. They use kind of a dendrometer to measure the diameter of the tree by checking kind of the voltage. They kind of wrap the equipment surrounding the tree and measure the voltage change along time. So through that, they can detect the change of the diameter of a tree. So with those two kind of measurements, they can actually associate the photosynthesis activity with the tree growth together. Let me scroll down a little bit, and you can see that's the citation. This is the table of contents of the entire user guide. That's the user dataset overview. And here you can see the related publication and the related dataset. These are really useful information for users to dig into some further details about the methodology. And those publications are also referenced throughout the user guide. And then section 2, that's data characteristics. And the one thing I want to mention is the data file details. And here is the table that lists all the locations of the trees that were measured in this study. there were, I think, 29 trees. They actually labeled every single tree, and they even have a photo of each single tree, which I'm going to show you shortly. Let me scroll down, and table 2 that contains the variable names and descriptions that they collected in the data files. And the companion files information here is actually, this data contains a series of companion files. Each companion file is a photo of a tree. Okay, again, I'm going to show you shortly. Section 3, the application and derivation is kind of a brief description of the potential use. What's the value of this data collected? And quality assessment, that's description of like calibration methodology. And here they have descriptions of how they calibrated both the dendrometer and the PRI radiometers. For the dendrometer, they even kind of test how temperature could affect the accuracy of the dendrometer measurements. And data acquisition, materials methods, this section contains detailed information of how the study was conducted and how the measurements were collected and any kind of post-processing they had to perform to put the data into the final usable form. And this is the study area. They actually had like how many 6 study plots as indicated by the red dots here. For every plot, they have a few trees identified and collected. And what were those trees? Okay, they have the sampling design, how the design was done. And this is actually one of the companion files that showed the tree that they measured. They even have a label, handheld label to label each single tree. And this was how they collected the institute PRI data. And they mentioned that they performed some post-processing, and that post-processing package was also included in the reference information. Okay, this was another tree. Okay. Okay, the reference information, you see this, the R package they used for the post-processing and additional papers that contain additional information. Regarding the companion file and how that are presented through the data package, that I have to go back to the dataset landing page. So this is the landing page. From here, you can download the files, and at the bottom of the landing page, there's a list of companion files. And again, you just have to sign in to download files. And you've seen some examples of the companion files. So that's a description. How long? Oh, 5 minutes. We're gonna go back to where is it? Okay. Ambiguities. Okay, again, this was mentioned by Bruce. I think there is unclear to me that where is the finish line when it's good enough. And also it's not clear to me that who should convey the requirements outlined in the PCS to investigators. Who has the authority to ask the investigators to meet those requirements? Do the DACs have those authority, and do the program funding programs have the authority? And should, for example, solicitation, ROSE's solicitation has some text or information about the requirements outlined in the PCS document. I think these are some of the ambiguities that I personally feel. So challenges, I think the biggest challenge is the resources for both the DACs and investigators. And this is especially critical for the small research projects that Bruce mentioned. I mean, it makes sense for large missions, large instrument teams, but for a lot of the small research projects that they did one-off study and should. Is there any sufficient resource available to support that additional requirement? Right, so right now, budget constraints is kind of everywhere. And also I feel, I don't think the investigators and the research community has been educated enough. For me, I think the PCS requirements are useful, not mostly in the DEX can preserve the stuff. It's more to tell or inform the researchers how they can improve their research study practices. And this needs to be done at the very early planning phase instead of during the project or even toward the end of the project. That's too late. Rama. Oh, yeah.
Hello.
I can only give my opinion
Mhm.
based on my past experience. About the question about who has the authority to ask, place the requirements. What we have done in the past is the so-called PLRA, the program level level 1 requirements. That's the program level requirement appendix, I think is what it stands for. Anyway, there the PCS is specified and is pointed to and said that the programs should meet those requirements. Okay. That's not the case, of course, with the RNA programs. For example, there is no such language in the measures. So the authority for that probably should come from the programming, program level funders. And in spite of its being a requirement, there is enough flexibility in the PCS that the intelligence on what needs to be preserved in each of those categories that we call for in that document, that knowledge comes from the investigators themselves. And investigators and DACs working together make a judgment on what's important to keep, what's more important to keep, and what's not practical to keep or not important to keep. That kind of judgment comes from there. So the specific items that go under each of them. In case of satellite missions, for example, you may have 500 documents that are relevant for a particular category. So you may end up with 1,000 items. In case of the R&A funded or field campaign, it may be only 10 items. But that judgment has to come from a collaboration between the DACs and the investigators.
Thanks.
And it's funny that Rama and I are sitting next to each other because we're the ones who worked on the PCS. So the latest version of the PCS is the one where, as lead of ADMG, I added a lot of airborne and field content to that because there really wasn't any in the original version. The intent is for that the DACs have an early communication with the scientists to say, think about your data. Think about in 10 years, if you had to pick your data up, what would you need? And the minute you say that to them, they go, oh yeah, okay, I'm going to need to give you this and this and this. And that's what dictates it. And it's different. Now, as far as seeing what you all keep, Dexing, I think you guys are right on the right track. I saw, there was Latin long in there, right? So there was the location, there was what was kept, there was pictures, there was where's the instruments, what did they look like? The only thing I didn't see was the model of the instruments that were placed, the dendrometer and that's the only thing I say would be the last thing. And then a link to, the instrument user guidebook or something. But for the most part, you're getting it right. And you're doing a lot more than we've seen before. So already it's way better, right?
That's a good example.
Yes, that's a really good example because I could show you some really, really bad examples. So, yeah. So I think that's the key is that we're already starting to think about this more, where before it wasn't thought of at all, and there was just a data set with no information to go with it. So kudos. Okay.
I think education process, and there are some that really sound well, they're not always fucking, do a good job. So when you convey the knowledge, give my opportunity to correct.
Yeah, just one more sentence. Even in case of satellite missions, we did not do this right in the beginning in the early 90s. We should have done that, but we did that in 2011, which is pretty late. So I guess we are backfilling all the information that we need to get from the EOS projects.
So we need to have the people from the future come back and tell us what they need us to research now. Okay, I feel like we're kind of loosey goosey, like time and structure, but I think that's okay, right? It's good. So our next speaker is, oh goodness, did I turn it off? Can you hear me? Okay, thought I turned it off. I just moved it. Our next speaker is Megan Bazanowicz. She's actually from ASDC, another NASA tech, and we're gonna have her speaking from remotely. So let me,
Stephanie, can you hear me?
yes, okay.
Okay, I wasn't sure it was gonna work, so.
You just made my life so much easier. I didn't I'm not really sure how to figure this out. So I'm gonna mute here so that you don't have a ton of feedback.
Okay.
I hope that works okay.
Yeah.
And just let me know when you want me to use your slides, because I have them all right here.
Perfect. All right, thank you all, and good afternoon, everyone. My name is Megan Bezanovich, and I support suborbital data and projects archived at the Atmospheric Science Data Center. Today, I'm just going to be reviewing the ASDC's efforts to complete the preservation of names and just some of my overall thoughts and takeaways from the process. Next slide, please. So before I dive into it, I did just want to provide a quick little overview of names just to set the stage and provide context for what information needed to be preserved. So NAMES, or the North Atlantic Aerosols and Marine Ecosystem Study, was a NASA Earth Venture Suborbital, or EVS-2 mission. NAMES utilized both aircraft and ship-based instrumentation across 4 deployments from 2015 through 2018 and collected both in situ and remote sensing measurements. Ingest, archive, and distribution of names data was completed at the ASDC in 2019. Next. So as preservation has evolved over the past few years to be more encompassing of suborbital data, the ASDC elected to complete preservation activities for names. We selected names. One of the primary reasons for the selection was that it was an EVS-2 mission, and the Earth Venture Suborbital is one of the larger funding mechanisms for suborbital campaigns, and typically provides great experience with a variety of platforms and measurements. So in September 2023, NAMES actually became the first suborbital mission to undergo preservation at the ASDC. And to do this, I did primarily utilize the PCS implementation guide version 1.0, as I believe Deborah had just mentioned. It was updated recently with a lot of very airborne specific guidance. So some of the documentation that we did go ahead and preserve or create were the flight catalog, the science, flight, and status reports, which obviously provide a lot of context about the flights and various statuses, such as if the instruments were working, which ones were working, which ones might have had a problem, things like that. We also included the weather outlooks with quick look and ancillary imagery, README files, and various instrumentation information, such as presentations that highlighted and described the instruments. The link to this is also available in our collection level metadata, so that provides users with an easy way to access it if they come in through Earth data. So as you can see here, this is our preservation page for names. Stephanie, if you hit the expand view button on the right, it'll expand and show everything. So we have the science reports, some of our quick looks and ancillary imagery, that we have some of the README files, the science proposals, supporting information, the flight reports, and things like that. So this was how we organized it, and this is how it currently looks when you go to the ASDC website. So just a quick look at that. Yep, and all our status reports. Yep. Let me go back to the slides. Thanks. I think, let's see, if you go to the next one. Yeah, and that was just an image. So this shows you where exactly you can, if you end up on our homepage, the arrow just, shows you where to go to click the preservation. So there's that. All right. So how does this meet or not meet the criteria? Loosely meet the criteria, I guess. We did create the investigation and flight catalog. It took some time, wrote all that information out and posted it on the preservation page. As I mentioned, and as we saw on the page, the science, flight, and status and ship reports were all included, at least the ones that were all readily available. I also included the instrumentation information and presentations to help users if they have questions about the instruments and provide important information and context surrounding those. Various aircraft videos that were taken during names are also included. They're on a separate page, but they are also readily available from the preservation page as well. But the videos are there, and we do have those available. I know the implementation guidance alludes to a field station name and location, so we didn't have any of those during names. So obviously that wasn't included. And the instrument operations and status are included in the status reports that I alluded to earlier in this discussion. Next slide. So just some overall challenges and thoughts that I've had while I was going through the names preservation and while I'm actually looking into preservation for our EVS-3 missions as they wrap up. So the first one I think of, and probably it's been mentioned a couple times by quite a few different folks in this room, is that one of, I think, the easiest steps we can take with respect to this is to ensure science teams are aware of the PCS and preservation as soon as possible, preferably as part of that initial onboarding and upon DAC assignment. And successful implementation of the PCS can also, I believe, be tied to robust data management plans. A lot of the necessary information can and should be included in those documents, and the DMP is alluded to quite frequently in the implementation guidance as places where that information might be. So proper DMP creation and honestly, subsequently proper preservation can be heavily supported by those early DAC assignments and interaction with the science teams. And with the implementation guidance and the PCS being updated in 2022, how do we approach completing this for legacy and completed projects? Is it something we even need to approach? Since the implementation guidance does provide certain levels of compliance, should there be an established level of compliance for those types of projects? With the increase of DAC assignments for these legacy missions, having some sort of expectation would be beneficial. And there are large suborbital projects like the early EVS missions that probably should undergo some type of preservation. So I know personally, I see a lot of legacy missions and a lot of legacy data. So having a good idea on how to handle those, I personally think would be beneficial. So next slide. And then just some other things I sort of noticed, some just verbiage differences across the documents. And I think it kind of goes back to what, again, folks have already mentioned is what is good enough? What is, chasing perfect, don't let perfect be the enemy of good or whatever. How do we, there's some, in the PCS, there's use of must be preserved. And then in the implementation guidance, like I alluded to, there are that acknowledgement of different levels of, checking those boxes. So what sort of, expectations are there, especially, we do have those different levels for like the RNA missions versus the EBS missions. So, just maybe clarifying some of those points would be beneficial. And maybe even, I know the implementation guidance does provide a lot of examples and the PCS verbiage does allude to that suborbital, but sometimes maybe providing a little bit more what in the actual PCS document might be beneficial. And then the implementation guidance acknowledges, the differences in suborbital versus orbiting. Apologies. And then, like I just said, and the level of effort for maintaining some of these documents can be high, particularly for DACs with a high number of suborbital projects. Like again, it's been a hot topic. Budget is tight, time is tight. What can be used to help streamline this process? I know, maintaining the checklist is a thing that we have to do. And something I read in one of the documents was about verifying the participants list. Well, lots of these science folks move around, move to different institutions, retire. So how is that sort of thing, what is the expectation of that being handled going forward? So let me see. I believe that should wrap up my yes, that wraps up my thoughts and my slides. If anyone has any questions for me now, I can take them, or if you want to shoot me an email, I'd be more than happy to respond. So thank you.
Go ahead.
Yeah, well, I have the mic here anyway, so I'll just go ahead. Well, I think she was saying earlier, Megan was saying earlier about informing the investigators early. And I think that information, informing them early should really come when proposals are called for. Yeah, right in the call for proposals, it should say that we are expecting that you will be preserving data, discuss about preserving the data that are called for in the PCS, or if you write a different PCS version for field campaigns, for example, follow that document or something. So that kind of thing should be there in the call for proposals, so that the people who are writing the proposals account for that right in the beginning.
I think that like it all goes back to resources challenge, right? And so when you're writing a science proposal for your field effort, you don't really have a real awareness of what the expectations are going to be on the data side of things, your ability to plan for what you think your budget's going to be. And I realize that longer term, there's other, mechanisms for that, but it's very, it can kind of feel a little bait and switch if you're a PI, right? To have to come in and get funded for this and then be like, oh, I have to do all this too. Well, no, that needs to be clear up front. And I think it would make it a lot smoother.
Right.
Else to add, if I may. Megan, regarding legacy, in this time of tight budgets, I think we can't be looking backwards, right? We've got a priority to look forward. So certainly I would say legacy is kind of one of those, it's a Friday afternoon, and if you happen to find a piece of paper that says something about some old campaign, and well, do something with it if you have a chance, but don't worry about going back. And I see Sarah shaking her head. No, don't do anything with it. Don't go chasing it down. Yeah.
Yeah, it's just something I thought about because, I'm sure Deborah, you're obviously well aware. It's something we
Yep.
see a lot of legacy data. So it comes across my screen quite often.
And the legacy data is what's of the poorest, which is the data that might want to be picked up now and can't really be because it doesn't have the needed information. The other thing you said is that there was, I'm wondering, you did a rather full and complete preservation step of having a page for it and having everything listed out. How much effort would you say it took, and what did you gain anything from it, and is there anything you would do differently?
So, like for full transparency, our website folks have they had set up the preservation page especially for all of our orbiting missions, so like tests and things like that have already gone through the phase F. So that is all. Thankfully, that piece of it was put into place already. So for me, it was just a matter of gaining access to the systems that I needed. There's some tweaks, just making sure I knew how to do it, and get access to what I needed to. So like that part of it, at least I didn't need to worry about. But actually, like putting the pieces into the back end, and I think the biggest thing I struggled with was how to line everything, I guess how to organize it more so than anything and fit it with the proper categories. Because again, we all know that the original PCS was written for and designed for orbiting. So where does each of my stuff fit? Trying to just do research as to what category I think it goes in. Is there a perfect category for it? Is this one just fine to put it in? So I think that part of it was probably the biggest time sink. Now, that being said, that's going to pay off now down the line because, I mentioned I'm working on our EVS-3 missions now. So, DCOTS and Activate. So, having that initial time sink for names and trying to wrap my head around it, I do think will go, will pay dividends here like right now because I'm going back and looking at the names page to say, oh, hey, where did I put this type of document? Oh, I put it here. Okay, so for consistency's sake, it's going here for DCOTS. Again, that might not be the right spot to put it in, but minor details. So did that answer the question?
Yeah, no, that's really helpful for us to hear is, input on, clarifications that could be helpful. So that there's not someone else out there who's doing that kind of walkthrough for the first time. Maybe we can, save them that step in the future.
And I will say when I was meeting with the end of the EVS-3 projects, I was explicitly saying to the teams that their data management plan was a living document. They to go back and clarify exactly what did happen in their data management plan so that it was available and would get stored as an updated document. And that's another thing that the DACs can certainly repeat to the EVSs as they're closing out, is to remind them to go back and make changes.
And again, updating after the fact, there's a new version of that product. Go back and update our checklist. That's an ongoing resource. It just adds up, particularly as was mentioned for DACs that have large numbers of. Okay, good things. We're going to move on to our next speaker, which is going to be Christine Lane. So thank you. Turn it all over to you. Should on. Oh, it's not in. Sorry. There you go.
Well, good afternoon, everybody. Do we need another stretch break? I kind of do. Yeah, so anyway, thanks for the great discussion so far. Christine Laney, I'm the lead for our informatics and data portal development at the National Ecological Observatory Network, or NEON. I'm based in Boulder, Colorado. So I'm just going to go through one slide about what NEON's about, just in case you don't know much about it, and then just talk about one of our data products as an example. Okay, so we are funded by the National Science Foundation, so not within the purview of NASA, but we have close ties with NASA, of course, and learned a lot about data management through NASA, but also through other NSF's funded projects. So we have 81 field sites across the United States, including in Puerto Rico and Hawaii. We are collecting over 180 data products, while making more than 180 data products available to end users free. They're open data. And the observatory is running for 30 years. And that 30-year time mark started in 2019, right before the pandemic, which is great. We had spent 7 years before that in construction. So we actually, though we are 5 years old officially in operations, we have some data sets that are spanning more than 10 years at this point. So we basically divide our data collection into 3 systems. We have airborne remote sensing, where we have camera data, hyperspectral, and waveform LiDAR. And then we also have automated instruments in all of the fields, in soils. We have flux towers, we have buoys and stream gauges and all sorts of things out there, over 16,000 instruments altogether. And then we do observational sampling, and this is everything from collecting soils, collecting water and doing chemical analyses, collecting organisms like beetles and mosquitoes, things that are relevant, kind of like the canary in the coal mine. They're indicator species. So we do a lot of vegetation work as well. And there's also, because we are flying over the sites and getting very high resolution data above the sites where we're also working on the ground and getting samples and everything, there are ways to scale that data. And so I should also mention that the data products are standardized across all of the sites as much as possible. So that's a little different than your typical PI driven research at each, where every location has different protocols implemented. Yeah, the data are also put in standardized formats. We've got a lot of standardized QA/QC protocols in it and things like that. So next one. So this is the example data product that I'm bringing to bear right now, but a lot of things that I'll talk about also apply to our instrumented and observational data products. So this is spectrometer or orthorectified surface bidirectional reflectance with mosaics. So this is a level 3 data product, very similar to how you would define it. In NASA, we have this bidirectional reflectance computed from our neon imaging spectrometer, which is AVRIS also. We mosaic those into 1 kilometer by 1 kilometer tiles, and we have one HDF5 file per tile that includes all of the reflectance data, the metadata, ancillary data, etc. So data product management, our basic metadata, we actually create ecological metadata language files for all of our data products. So we have all of the most basic metadata in that: abstract, the sensor, the date range, the sites, all of those things in the EML files. But we also have more detailed metadata within the HDF5 files, things like ancillary imagery, coordinate system information, data collection, input and processing information, and so forth. All of our data can be accessed and discovered through Neon's data portal. We also have a public API. We also have an R package called Neon Utilities, and we're building out a Python package to do the same things that our R package does. We're also exploring Google Earth Engine as a cloud-based discovery and analysis platform, and we are hoping to roll out public access to data on that platform fairly soon. It would be some of our less derived products, I think. That's coming soon. One of the things that we also have are what we call data product revisions. And so we can revise a data product when we change out an instrument or a protocol, and there may not be comparability from that one older version to the next revision. And so I specifically picked this data product because we are in Rev 2, where we changed from directional reflectance to bidirectional reflectance, and we made some adjustments to the calibration, to some of the other things, maybe corrections, and we also so actually they show up on the data portal like this, basically like 2 different data products, but one links or refers back to the other one. And what we've done is we've just started publishing this new revision for the 2022 flights. We're going to work backward all the way back to 2013 and get those cleaned up, and then we're going to move forward on this. So that's what that's looking like. Stretch break, anyone? All right. So our data are always provisional, first published as provisional data. We have a new DOI annotated release every January. That's the cleanest, most quality check data that we have to date. It may, we have some corrections based on user input and things like that. But one of the big challenges for us is that data volumes, it costs money, right, to store and to provide egress for that data. And so what we find is that with our instrumented and observations data, we can store and provide access to every single data release, I think, through the lifetime of the observatory, every annual release. However, with our remote sensing data, it's really big. And we, to be able to provide all of the raw data is just not within our abilities. So what we're doing here is different, that we are archiving in cold storage the low level data, the older releases and older revisions. The derived data are overwritten. And then the DOIs that were generated for the old releases are tombstone. So that's unfortunate, but that is the state of the funding. Documentation, we also provide, in addition to everything, the email and issue 5, we provide flight reports specific to the flights that we had. We have quick start guides to get people up and running with what the data are about and how to start using them. And then we go down to more detailed documents like our HUBDs, the algorithm documents. What we find the other challenge here is that when you take this whole body of information and think about, most users aren't going to just use one of our data products. They want to combine lots of data products, and they all have lots and lots and lots, like hundreds of pages of documentation. People just wear out. They don't know. They don't want, they're trying to read all of this stuff and they're like, I don't know how to deal with all of this. And so we find that people end up missing really key information about, how the data were collected, how they were calibrated, what the quality flags are, how they should deal with quality, that kind of thing. So it's a big challenge for us. And finally, we do provide data notifications to people who sign up for those. We have an opt-in system. So if there's any data quality issues or challenges or upcoming revisions or anything, we can let people know, but they do have to opt into that. And finally, we provide a lot of tutorials. So we have over 200 tutorials at Neon. Some are just general data science. How do you work with GitHub? How do you work with R? And then some are very specific to the data product. So this is an example that's using this particular data product that I was talking about. And that's it. So thank you. And open for questions.
Just a nomenclature question. When you said a new DOI annotated version is January, can you explain a little more what you mean by that?
Yeah, so every January we go through I should say starting right now in July or so, we start reviewing all of our data products and start reprocessing anything that needs to be reprocessed, republishing everything. So a data product release is all of the data for that data product for all time, for all sites. And so we put a DOI, once we make that snapshot of the data, and that's going to have a bit of a gap between when the data were most recently collected and the day that we actually release it, because we want to make sure we only have the quality check data in that release. But that whole package, so all the sites, all the date ranges, everything for that data product, that's a release, and we put a DOI on that. Does that answer your question, Bruce?
I have it's a half comment, half question. One of the things I find frustrating is things like flight reports. There's no standardization at all. Do you see that across Neon as well? Or within the organization, do you have any kind of standardization of what a flight report should look like?
Yeah, I mean, I think I see standardization in the fact that we have a template and that our scientists can input information into that template, but in terms of machine readability, it's not there. We don't have that set up in a way that's easy for a machine to read.
Yeah, and that's like when I retire, that's one thing I want to do is play with flight report standardization.
Yeah,
It'd
it'd
be
be really
fun.
cool. I would love to hear if anyone's working on that, honestly.
I haven't heard of anybody working on it. I wish I had the time.
Okay.
I had a question about the tutorial information that you mentioned having. Oh, I can pass you the mic too. Sorry. So you mentioned having tutorial information on like R and GitHub and other things. I was wondering how specific they were to the Neon project, or versus how general and generic and potentially reusable they could be across communities.
Yep, yep. Some of them are really general, like our ones on how to use GitHub. That can be applied for anybody really. And also some of we have like tutorials on just hyperspectral data, not necessarily Neon's hyperspectral data, though they are, a little weird because you have to have an example. And so we say, okay, go download this data and start using it. But it really goes through the whole conceptual process, not so much the specific. And then we actually, I would say that fewer of our tutorials are very data product specific because it takes so much energy and time to build ones that are specific.
Okay. Next, we have Shannon Leslie. Excited to see.
Hey, anyone else? Very cold. Cause I am. So I don't have slides. I'll try to be quick. I think we only have like 10 minutes left in the session. And besides, I think everyone who spoke before me probably spoke to many of the same challenges I would want to mention, but I will. So I did pick just an Icebridge data set. So sorry, I'm Shannon Leslie. I'm the data stewardship lead at the National Snow and Ice Data Center, DAC. And we manage the Operation Icebridge Airborne mission, a lot of data products from a lot of platforms, a lot of sensors, over I think about 8 years or so. And I could have picked probably any data set to highlight like challenges with PCS or just general data usability. But this one was an interesting one because it has two versions and for this single data set, it's managed by two different facilities. And so version 1 sort of is a more complete temporally data set, but version 2 was reprocessed by one of the facilities to update some issues we found with the files. So version 2 is not as temporally complete, but sort of a higher quality. So one of the facilities just didn't sort of respond to our request for, hey, can you fix issues? So I think that was my sort of one of the biggest challenges for us in implementing PCS, which Xing and others spoke to, is really like the DAC's authority. So much of what is in the PCS needs to come from the data providers, comes from the data producers. And I think at the DACs, we don't have much authority to say you must provide X. And I think, in terms of, I guess I'll kind of go back to what we do well, what we've done well. I will say the DAC curated information, the stuff we kind of take the lead on curating, similar to ORNL. We curate user guides. We provide a bunch of information in there that is sort of part of the PCS criteria, like platform, instrument, algorithm information, versioning, that sort of thing. So I think we can do that well because, again, that's something we have expertise in, curating that type of information. But we're typically not in the field. That has changed some. We have been in the field lately, but kind of goes back to the investigators. So I think that kind of gets into the ambiguities and challenges, sort of who's ultimately responsible for this information. I know in the PCS, we've sort of talked about us sharing the PCS earlier in the project process. I would take it a step further and even changing the language in that document to even say sort of who's responsible, who supports this, because I think there's a lot of language around the DACs are responsible for X. And I think that, ultimately we are reliant on the data producers for this type of information. I think data management plans is another thing that has come up here. And I know we have templates out there, and I think for satellite missions, they're a little bit better, but I think there's some improvements that we could at least make in data management plans to kind of, there is a data management plan at the mission level. So for Icebridge as a whole, not nearly enough detail to kind of get at a lot of what's in the PCS, like nothing at the product level. So there's just a lot of inconsistencies based on what the data provider is willing to do or is funding to do, whatnot, and what they've provided to us. So we've sort of just provided what they have provided to us. The only other thing I wanted to mention that I think hasn't really been discussed is just we've put together some lists, like based on the PCS checklist, lists of documents on a web page, but I think that could lead to a lot of redundancy in where documents live. So we've tried to do a little bit of work figuring out where to point to documents that maybe live on some other NASA site, but I think technology can help here where, like a enterprise document management system and these sorts of things. So we're not like putting documents, if I don't know, Elvis or some airborne facility, that those data are managed at a couple different DACs. We don't all want to be posting the same document 4 times. So, and I think the same goes for sort of software and code. I think Ornell is like, a great solution in place, but I think we don't really have a place right now to archive software code. There aren't really guidelines out there for that, but that is part of PCS. So I think that's another challenge, a big one. Okay. So I think it's probably, I think that's good for now. So thanks. I mean, just pass the mic around. No,
I want to take it first. I have a question, I think for all the speakers at large and PCS architects in general. I've been having a hard time wrapping my brain around, in particular, where is the good enough line to be drawn in with respect to specifically reproducibility? But it's been very hard to know how far do you go? If you have an ATBD document, is that good enough? Oh, well, you need to have, this is the software algorithm. Okay, that's good enough. Well, what software did it run on? What libraries were needed? What OS was that? What machine was it? In 20 years from now, are we going to be back at magnetic spinning disks? Like, at what point do you say enough is enough? If we're talking 20, 25 years from now, our technologies aren't going to be readable then. Does it matter? Does it make sense? Where do you draw that line? And I'm curious
So-
about opinions.
One answer to that, and this is part of a way to interpret the PCS, is that it depends. And that a key responsibility for a data archive is to say, here's what's in our checklist, here's what's not in our checklist and why. And keeping that information with the data set. We'll get some of those decisions right. We'll get some of them that in hindsight, we might wish we'd made a different decision, but we will have made the best decision that we know how to make with the information, resources, and skills to hand at that moment. Agile Prime Directive, go read it.
Yeah, before we hang up and leave, I just want to make one comment because you brought up earlier that it may be desirable to have a separate adjunct to this document or perhaps a separate chapter in the document regarding the airborne and field campaign data. So if you're going to do that, the ISO 19165-2, which is a ISO standard that I worked on, largely based on PCS, which preceded it, and also a CEOS created document, CEOS ESA created document. Those were the inputs to that standard. And that got standardized and approved in 2020, which means 2025 is the year when that's going to come up for review and renewal. You either renew it or abandon it. So that's the stage for that international standard. And it would be highly desirable if some attention is paid to that standard as well, if you're going to go through the process of PCS adjustments.
And I have a question for Rama and Deborah. How much were the investigators and the data producers engaged when you were writing the PCS, especially the airborne build component? I feel their engagement and inputs are quite important.
So at the time, EVS was just spinning up when I was working on the PCS with Rama and John, and not much. You know, honestly, the investigators are paid to do their science and not much more. They don't make a lot doing it. So they look at us when we start talking data, like, that's your job, take care of it, please. Right. And so I think the key is that it's up to us. You said you need stuff from them. It's up to us to say, I need this from you in order to make sure this data is going to be usable later. And they're more than happy to oblige if you just tell them what you need, because they can't think about it for us, you
A
know?
lot of times those things are easy for them to provide.
Yeah.
They're like, oh.
They just need to be told that
Okay,
you need it. And they just don't have the time to think about what you need, because thinking about the data preservation is nothing on their radar unless you say to them, do you want to be able to use it in 10 years? Then give me these, this and this and this. I think those are the things. Do you agree? And if you have that conversation with them, they're more than willing. And if you ever bump against one that's not, you get the PI involved, because he's more than willing, or she is more than willing. That's what I find. And if not, that's what Airborne Data Management Group is now here for. This is what we are to do, is to help smooth that conversation and make sure that they understand that this is important. We're here to help make sure the data is well cared for. And we're not talking about authority so much as just, let's work together to get it done right.
And I think that's where I'd make a point, or as a philosophy, whether it's PCS, whether it's an ISO standard. I think what I'm doing with that depends a little bit. If it's a facility instrument, I'm inclined to hand them the PCS and say, here's the document you need to be aware of. If it's an investigator-led project, I'm more inclined to say, here's this document over here. Here's what it means for you. This is the stuff that we're after in this case. And I think that's a restatement in other words
Right.
of what you're saying.
But the other thing is the PCS did go through review. Right? So if there were some PIs in that, and I don't know how many were, they would have gotten some ability to add feedback. But honestly, I don't think there were many. They don't have the time. What I did do is put into there things that I know from their comments in meetings that I was attending with the scientists, that they mention of being important to using that data. Then I go click, all right, put that in the PCS, right? So I was the conduit between the 5 EVSs and the improving of the PCS. And from being in their meetings and taking it back to the PCS is pretty much how it got there.
Yeah, their thoughts could be different depending on this to be a voluntary efforts or a requirement that's going to be written in to the solicitation. And also I have to second Shannon's comment on that. A lot of the stuff they did come from the investigator. If they have not done a good job, we won't be able to go any further along that direction.
All right.
Yeah.
Think we have to call it. I'm really glad that we've had such good discussion here. Thank you all for taking time. I know it's competing stuff, trying to choose where you're going to spend your time. As you said, so I really appreciate that you're part of this session. And yeah, and please continue to, have these discussions and involve the folks in this session and myself and others, as much as possible. And yeah, and I do have a badge. I just realized I don't know where it is now. But I'm Stephanie, if you didn't already know that. And yeah, thank you all.